Mohammed, the chemistry guru of Mangwa School. I normally believe that chemistry is a subject that students should pass. In my classes, they normally tell me that they booster subject. Every student, and even in the cases, a child unaona mapata D+ na kema kuna A plane akiwa kwa darasa langu, kwa sababu I make it simple for students. But there are certain concepts that are not in the textbook. Ya kwanza ni why we want to explain what is a metallic bond and which factors affect it. Because when you are asked to compare melting point of element in group 1, group 2 transition element, and group 3, they are just asking you to compare the strength of the metallic bond, because we are going to use heat to break the metallic bond. So the stronger the metallic bond, the more the heat required to overcome the metallic bond, hence the higher the melting point. So there's a scenario here. Let's take example of alkali metals. Alkali metals, let's say sodium and potassium. Now, kwa kitabu wanaandikanga that the higher the number of delocalized electrons, the stronger the metallic bond. Now let me ask you something. Hizi mbili, see, the number of delocalized electrons are all the same. That means atomic radius contributes here, because lithium has the highest melting point than this and this, due to the fact that its atoms are very small, hence very strong metallic bond. What is simply metallic bond is? Metallic bond is simply electrostatic attraction between the nucleus of an atom, of an element, to the delocalized electrons. What are delocalized electrons? This electron, the outermost energy level of metals, are normally free to move independently. See, so within a structure of potassium, the lattice structure, the metallic structure, there will be million of atoms and there will be million of delocalized electrons moving about, and then the nucleus of potassium attracts them. So the further the distance from the nucleus to the delocalized electron, the weaker the metallic bond. The nearer to the delocalized electron to the nucleus, the stronger the metallic bond. So lithium, having a small atomic radius, has stronger metallic bonds than sodium and potassium. As a result, if I require to heat lithium to melt, I require a lot of heat than melting sodium, and even potassium will even be less, because the metallic bonds here are very strong due to the small atomic radius. Now let us go to alkaline earth metals. So here we have beryllium, we have magnesium, and then we have our calcium here. Now this is the electronic arrangement of calcium, electronic arrangement of magnesium, and the electronic arrangement of beryllium. Now, so we expect the beryllium and magnesium and calcium atoms, we expect the beryllium to have stronger metallic bond due to the small size of the atom. Because metallic bond is simply electrostatic attraction between the nucleus of the atoms and the delocalized electrons. Now, magnesium ideally should have high melting point than calcium, because it has a small atomic radius. But when you go to the textbook, unapata wameandika the melting point of calcium is higher than magnesium, while beryllium is higher than calcium. So hapa iko tu sawa, lakini hapa kuna kidogo inachanganya wanafunzi. So today I'm here because niliona mtoto ameandika kwa comment section, nimwambie why the fact that calcium is big, the metallic bonds are stronger, hence require a lot of heat to break it, than magnesium. It is simply to have the structure, the shape of structure of calcium, and the shape of structure of magnesium. Now, what have we said? What is metallic bond? Metallic bond is electrostatic attraction between the nucleus and the delocalized electrons. So the nearer the delocalized electron to the nucleus, the stronger the metallic bond. But calcium, beryllium, meaning it has very small, a strong metallic bond because the atom is so small, the nucleus are very close to the delocalized electrons. So we expect magnesium, because it has a small atomic size, to the atoms that is equal closer to the delocalized electron than calcium, means high melting. But that is not true. Calcium still have high melting point than magnesium. So we cannot use only atomic radius to compare melting point. A student have asked, it's normally this thing. The way the structure of calcium is and the way the structure of magnesium is makes that difference. Now, the metallic structure, the atoms in a metallic structure of magnesium, the atoms are arranged in hexagonal manner. Now, if I assume these are the delocalized electrons, this distant from the here, this distant from here, this distant from here, this distant from here. There are some delocalized electrons all over, so attracting. So then let's now draw the structure of. So it is simply this. So what is the difference? The metallic structure in calcium is cuboid. So these are the atoms, 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 these are the atoms. So the distance from the delocalized electron to the nucleus are very close, hence very strong metallic bond. So this is to how the structure of calcium is and how the structure of magnesium is. So the way the atoms of magnesium are arranged make the atoms, their nucleus, ikuwe mbali sana na delocalized electron. So the metallic bonds become weaker. Lakini calcium, the way the atoms are arranged within its structure in cuboid makes the atoms to be very close to the delocalized electron, and that makes the metallic bond to be strong. So the difference between melting point in magnesium and calcium, magnesium ni ndogo na calcium ni kubwa, so the atom, so una expect the metallic bond inakuwa strong. Hiyo hakuna. In magnesium and calcium kuna certain phenomenon that is specific about how the atoms are arranged within the structure. Within the structure of magnesium, they are normally arranged in hexagonal manner, and that makes the nucleus to be very far from the delocalized electrons. In calcium, the metallic structure, the atoms are arranged in cuboid manner. That makes the nucleus to be very close to the delocalized electrons, hence making magnesium to a very calcium to a very high melting point than magnesium. But the beryllium one is it. The smaller the atomic radius, the stronger the metallic bond, the higher the heat required to break the metallic bond. So we were just trying to bring this fact because it is not in YouTube. Mimi ndo nimekuwekea kwa YouTube ya kwanza. Nimefanya research yangu. Nimeangalia na nuclear magnetic resonance, structure hii na structure hii. So the metallic structure za calcium na magnesium ziko tofauti. Hii iko cuboid, hii iko hexagonal, and that makes the distance from the nucleus, delocalized electron go mbali. The cuboid makes the distance from the nucleus, the delocalized electrons go karibu, and that's what makes it to a high melting point. So you require a lot of heat to overcome the metallic bond here than here. No. So, wanafunzi, apart from calcium and magnesium, those are the only ones that bring a different shifting pattern. But ideally, the smaller the atomic size, the stronger the metallic bond. Wanafunzi wengi maswali nauliza, compare the melting point of this and this. If I'm told to compare melting points, I'm being told to say which one of these two requires a lot of heat to break the structure. So if I'm asked between sodium and magnesium, which one has high melting point? It is magnesium. Why? Magnesium atom yake ni ndogo. So the nucleus, we know how to compare atomic radius across the period. You know that as you go across the period, the number of protons increases. So as the metallic bond. Meaning, unless this one is in a later isotophobe. Because there are two factors that affect metallic bond. The size of the atom. That is the major factor that creates the metallic bond to be very strong. Except here and here, where these atoms are bigger than this one, but the difference is the distance. So structure, a metallic structure of calcium is cuboid, metallic structure of magnesium is hexagonal. The atoms are arranged in hexagonal manner, and that's what may break the difference. Another student has also asked me this. A student has also asked me to explain why, when I add sodium hydroxide through a solution containing calcium ions, the white precipitate with sodium hydroxide, but ammonium hydroxide does not form precipitate. I'll explain that still. Thank you.
Iliandika hapo 14 minutes pekee.